Today we continue our discussion on the distributive property with day 2, and today our main focus is going to be to use the distributive property in the algebraic sense. So yesterday we did the distributive property with numbers. Today we are going to be doing the distributive property using numbers and algebraic terms with variables, so variable terms in other words. Okay, so let's get right into our review. So, like we said yesterday, the distributive property states that to multiply a sum or a difference by a number, you multiply each term inside the parentheses by the number outside of the parentheses. So as we said yesterday, in the case of 4 times the quantity 6 plus 2, I multiply 4 by 6 and by 2, and I retain that addition sign. Okay, same for subtraction. And we got a lot of practice with that yesterday. Today we're going to be applying it to terms that contain variables. So before we do that, we need to talk about what equivalent expressions are, because today we're not going to come down to an answer that was like yesterday where we said, oh, the answer is 14, or in this case it would be 24 plus 8, which is 32. We're not going to get to an answer. We're actually going to get to two-term expressions today. So if I take a look at the expression 2 times the quantity x plus 2, I'm looking at distributing that 2 to get an expression of 2x plus 4. So that would be the kind of answer I'm looking for today. I'm looking for a simplified equivalent expression. So no matter what x, these expressions will always hold the same value. So it doesn't matter what x is. If x is 2, for example, 2 times the quantity 2 plus 2, that would be 2 times 4, which is 8. 2 times 2 is 4, 4 plus 4 is 8, so you would still have an equivalent expression. Alright, so before we get into that, a quick note to yourself. When we are adding numbers, for example 4 plus 5, it's really easy for me to say, well, 4 plus 5 is 9. It's because I have 4 numbers here and I have 5 numbers here, and if I count 4 tallies and 5 tallies, that makes 9 total. Well, if I'm adding, let's say 4 plus a variable. Now that's 4 tallies, but that's 1 I can't combine those, so I have to leave it as 4 plus m. But let's say I was adding 4 plus 2m plus 3m. Now, in this case, I have 4, I have m, and I have m, and m. So I technically have 4 and 5m. So my answer in this case would be 4 plus 5m. For proper notation, we always write our variable term first. So I'd have 5m plus 4 would actually be my simplified expression. All right, so why are we looking at this? Well, today we're looking at using the distributive property with expressions that contain variables. So when we're using the distributive property, it's going to be the same as what we did yesterday. I have 4 multiplied by the quantity x plus 7. They just want you to rewrite this as an equivalent expression. So in this case, if I'm doing 4 times the quantity x plus 7, just like I did yesterday, I know that this is going to be equal to 4 times x plus 4 times 7. I don't know what x is, so I'm going to leave that as 4x, because remember, 4 times x can just be written as 4x. But I know that 4 times 7 is 28. And this is actually my final answer in this case. Okay? Let's try that again. So if I'm looking at 11 times the quantity x plus 5, again, I'm looking at 11 times x, retain that plus, 11 times 5, so that's going to be 11 times x plus 11 times 5 using the distributive property. I get 11x plus 55. And again, I cannot combine those any further, so this is my final answer. All right, we've got a lot of examples to do today, so hopefully by the end of this lesson, with all of the examples we're going to do, this will make a lot of sense. All right, so let's try it with some basic subtraction. So 6 times the quantity p minus 5. Again, I know I'm going to multiply 6 by p, 6 by 5, and I'm going to retain that minus sign. So I'm going to have 6 times p minus 6 times 5, that's 6p minus 30, and I am done. Alright, so at this point I think it would be a good time for you to pause the video and try this next one on your own before I put the answer up. Alright, so let's get that answer up. 5 times the quantity p minus 8. So again, it's going to be 5 times p minus 5 times 8. Which gives me 5p minus 40. Alright, hopefully we're starting to get the hang of this. Let's try some more examples. Now, yesterday we talked about this a little bit whenever you have the minus sign or the negative sign outside of the parentheses. So today we're actually going to look at some examples in our video to make sure we really understand what to do with that negative. So I have negative 2 times the quantity x minus 8. So again, I know I'm multiplying by the first term, I know I'm multiplying by the second term, and I'm subtracting. So let's see what that looks like. So that looks like negative 2 multiplied by x minus negative 2 multiplied by negative 8. Whoops, sorry. Not negative 8, but 8. Because this minus here comes down right there. That's a positive 8 then. And then that negative was attached to the 2. So I have negative 2x minus, well, negative 2 times 8 is negative 16. But we know whenever we are subtracting a negative, that's the same as adding. So I get a final answer of negative 2x plus 16. Okay? Let's try that again. Negative 3 times the quantity x minus 2. Like we just did. I'm going to multiply by each of those terms. Bring that minus over. So I'm going to have negative 3 times x minus negative 3 times 2. That's negative 3x minus negative 6, which becomes negative 3x plus 6. Final answer. Okay? Well, let's try another problem. Alright, use the distributive property to rewrite 5 times the quantity negative 3x plus 7y. Okay, so here's a problem where we have coefficients in front of the variables, or in other words, we have numbers that are already being multiplied by the variables. But no worries, this is something we can do. So I have 5 times the quantity negative 3x plus 7y, and I want to know what that is. So as always, I know when I distribute, it's going to be 5 times the first term plus 5 times the second term. So let's at least write out what we know. So that's going to be 5 times negative 3x plus 5 times 7y. Now, 5 times negative 3x. Whenever I see a number being multiplied by a variable term that contains a coefficient such as this 3 here, you just multiply the numbers together. So this would become negative 15x plus 35y. And here's why that works. So if I have 5 times negative 3x, that's saying that I have 5 groups of negative 3x, so that means I have negative 3x, negative 3x, negative 3x, negative 3x, and another negative 3x. Well, I know each of these contains 3 negative x's. So in other words, I have 15 negative x's, or negative 15x. Okay? Let's try another one. And again, at this point, if you feel confident enough to pause the video and try ahead of me, that would be perfect. All right, so I've got 4 times the quantity, negative 9x plus 1. So I know I'm going to distribute, and this time I drew my arrows above the problem. You can either draw them below or above the problem, whatever's more comfortable for you. So I know this is going to be 4 multiplied by negative 9x plus 4 multiplied by 1. according to what we just did in the last example, 4 times negative 9x, I'm just going to multiply the numbers. It's going to be negative 36x plus 4. Final answer. Okay? Got one more set of examples before we get to the problem of the day. And these contain fractions. Now with fractions, we know how to multiply fractions and numbers. That should be the easy part. What do we do once we hit the variable? Nothing new is going to happen here. We're still going to multiply as we would with whole number coefficients or integer coefficients. We've got 1/3 times the quantity x minus 6. So I'm distributing. Well, according to what we have been doing, that's going to be 1/3 multiplied by x minus 1/3 multiplied by 6. Well, that 1/3 x I'm going to leave as 1/3 x. I can't do anything more with that. But 1/3 multiplied by 6, I know I could do something there. That's going to be 1 times 6, which is 6, over 3. 3 times 1 is 3. But I can reduce that further. So I'm going to get 1/3 x minus 6 divided by 3 is 2. And there's my final answer. All right, let's get to that last example before the problem of the day. Use the distributive property to rewrite 1/4 times the quantity x minus 6. Again, try to pause and work ahead of me just to see if you're really getting it. Okay, so I know I'm going to distribute that 1/4 to each of the terms by multiplication. So I'm going to get 1/4 x minus 1/4 multiplied by 16. Well, again, that 1/4 x, I'm just going to leave it as 1/4 x. But then I'm going to actually multiply that fraction by that whole number. So 1 times 16 is 16. 4 times 1 is 4. Well, that simplifies out to 1/4 x minus 4. Oop. And that should be a 4. So my final answer, which I'm going to rewrite, is 1/4 x minus 4. Okay, so let's take a look at that problem of the day. Here's your problem of the day, the first thing that we'll go over tomorrow when we get to class. Good luck, have a great night, and I'll see you tomorrow.